Welcome back, guys. We'll be sorting today's 1000 rated question. So the question's name is Bogosort, and the question says that you are given an array, and an array is good for if for each pair that I and j are indexes. So for each pair, if this condition holds, that is j minus a at j should not be equal to I minus a of I. Can you shuffle an array so that it becomes good? To shuffle an array means to reorder it. Let's look at the constraints. The test cases are 100 and each element lies from 1 to 100, and the length of the array is till 100 only. So this is all the information we have, that we need to select any two for all two indexes. For all such combinations, this condition should not hold true. But as you can see, this condition, in this condition, j is the position and a of j is the value. So for each j and I, we are checking that the position minus its value should not be equal to any other position minus its value. So if we rephrase this, because this is a position and value, right? At LHS there is only let me rephrase. At one side of the inequality there are two variables, so position and value. So we need to make it simpler, we'll just combine all the positions to one side and all the values to other side. So on reordering this, it becomes j minus I should not be equal to a of j minus a of I. That is, the difference of two positions should not be equal to the difference of values at those two positions. This condition should hold for all different pairs of j and I. And j and I, just a second, j and I belong from the length of the string, the length of the array, till the first position. That these are indices directly, so I'll directly write 0. Okay, so index 0 till the last index. For all these different pairs, this condition should be valid. So how can we proceed? Let's say we are given an array, okay, a1, a2, a3, a4, a5. The condition says that for all different indices, this should not be equal to, right? That means this condition should hold. So for example, we'll just take that, let I be equals to position index 1 and j equals to index 3. So it becomes 3 minus 1 should not be equal to a at 3, that is the value at position 3, minus value at position 1, which becomes 2 should not be equal to a of 3 minus 1. That means if we use this condition on j equals to 3 and I is equal to 1, this is an inequality we must satisfy. Similarly, there are many other inequalities we need to satisfy to make this array good according to the question. So for each condition, we need to find some pattern. So what is the pattern? What all observations can you make? As you can see that we'll just note down the facts, okay, whatever we know. We know that we'll consider I as the lesser one among the two indices that we select, and j as the greater one among those. And both of these lie between 0 to n minus 1, right? It is inequality here. From 0 to n minus 1, we know this because indices of an array lie from a of 0 till a of n minus 1, right? Indices itself lie from 0 to n minus 1. So what can we make a comment on? We can make a comment on j minus I, right? Because as we know this, we can guess that what is the range of j minus I. So j minus I, which is equal to the left hand side of our inequality, as you can notice, the difference of two positions. So we can as we know this, we can make a comment on the difference of positions, that the difference of positions will range from 1 till n minus 1, because they lie from 0 to n minus 1 and they are not equal. One position is always lesser or greater than the other position, right? This is a condition. So the difference among these two will always be greater than 1, greater than equal to 1, and less than equal to n minus 1, right? So for example, this will happen when let's say I is equal to 4 and j is equal to 2, and this will happen when, let's say, I is equal to 0 and j is equal to n minus 1. Yeah, these are the two cases, just for example. Okay, So as we know that the difference of positions lies from 1 to n minus 1, and what do we need to hold the satisfaction, that the differences should not be equal to the difference the difference of the values present there. So what can we do? So the differences lie from 1 to n minus 1. So one of the approaches is that to satisfy the inequality, that means this difference j minus I should not be equal to this value, right? The RHS, that is a of j minus a of I. So this a of j minus a of I, the RHS, will pass on to the extreme cases, that as this value is greater than equal to 1, we'll say that the other value at the RHS should be less than 1, should be either less than 1. Or another case is that if this value, the difference of the positions, is less than equal to n minus 1, then we'll set the difference of those values as greater than n minus 1, greater than n minus 1. And in both these conditions the inequality holds, right? Because this lies from here to here, so we'll directly say that let the RHS be all the numbers except this range, that is it should be less than 1, because here as it is greater than equal to 1, and here RHS should be or else greater than n minus 1, because here it is less than equal to n minus 1, right? So what we are doing is that if this is a number line, and according to the number line, let's say up to minus infinity, and here 0 1 like to infinity. So according to the inequality that j minus I lies from 1 to n minus 1, let's say this condition on a number line represents this, that it lies from 1 to some n minus 1. Okay, let's say this is n minus 1. This is LHS j minus I. So we'll say that the RHS, which is a of j minus a of I, and this inequality should hold. So we'll say that this RHS should be all the numbers except this, because if we remove this, that's when the inequality holds. So we say that let the RHS be all the numbers except these numbers. So this is the solution we are approaching this problem with. So okay, these are the two conditions we have observed, right? It should be either less than 1 or greater than n minus 1. Now we need to check, is it possible to make the RHS like this, because this is just a comment we have passed on the RHS, but according to the given array we need to state, right, whether this is possible or not. Now according to the given array, each number lies from 1 to 100. According to the given question, each number lies from 1 to 100. So the difference of the two numbers will lie from 0 till 99, right? Let me write it clearly. So the difference of two numbers, according to this condition, the difference of two numbers a of j minus a of I will lie from 0, because the numbers itself can be same, that will be the minimum case, and the other case will be when one of the numbers is 100 and the other number is 1. So the difference at that time will be maximum, which is equal to 99. So the differences of numbers lies from 0 to 99. But if you can observe that according to the question we have fixed that j will be an index greater than I. When we choose j and I, we have clearly stated here that I is lesser than j. So when we do this, if we sort, that means the difference of the two elements depends on its position. This a of j will be present towards the right of I, right? So in an array a of I and a of j, just a minute, I'll write it clearly. So according to this is the given array, right? General case, I'll start with a general case. So this is an array, and we have stated that the two indices that we choose, in this case it is 1 and 3. The I will be the one which will be lesser, which will be at the lesser index, and j will be at a greater index, right? Among the two chosen indexes, I will be the one which is lesser and j will be the one which is greater. So the difference of the indices itself, the differences of the indices itself should not be equal to the differences of the values of those indices. That means j minus I should not be equal to value at j minus value at I. So the value which is at a greater position minus value which is at the lesser position. Okay, got it? So as all these numbers lie from 1 to 100, the differences can range from, the maximum difference that we can achieve is when let's say a of j is equal to 100 and a of I is equal to 1, so 99. And the minimum difference we can achieve will be reverse of that, that is minus 99. Why? Because we can say that let a of j is equal to 1 and a of I is equal to 100, right? So we say that let this be equal to 100 and this be equal to 1. In this case, a of j minus a of I will become minus 99, that is the difference becomes minimum. And as the difference of positions can only range from 0, because we have stated here, right? Just a second. That the difference of positions can lie from, just a minute, can lie from 1 to n minus 1, and we can say that the difference of the values lie from minus 99 to 99. It is possible to include this case, which is the difference should be less than 1, because we can find the cases where the difference is negative. So the solution is that when we arrange the elements, we'll arrange in such a way that the values, the differences, the a of j minus a of I will become negative. So to make this happen, we need to write an array which is in descending order. So for example, let's say I take an array 1 2 7 3 4. This is an array which we need to convert to a good array. So my approach is that we'll sort it in descending order. On doing that, it will become 7 4 3 2 1. Let's check if this is good. So let's say I'll say I is equal to 4 and j is equal to, I is equal to 3 and j is equal to 4, because I is the one which is the lower index and j will be the one which has the higher index, and the indexes are 0 1 2 3 4. These are the indexes. So a of what we should satisfy that j minus I should not be equal to a of j minus a of I. J is equal to 4, I is equal to 3. It should not be equal to a of j. What is a of 4? A of 4 is 1 minus a of I is a of 1, a of 3 is 2. So it becomes 4 minus 3, which is 1, should not be equal to minus 1. Okay, this condition is satisfied, that the difference of positions which will always range, the difference of positions j minus I which will always lie from 1 till n minus 1. This is the LHS, right? The LHS, the difference of positions, should not be equal to difference of the values at that position, which will lie from, which we say that it will always come negative. RHS. Why? Because as we have arranged the array in descending order. As we have arranged the array in descending order, the difference of two values such that it will be like the element at greater position minus element at lesser position. It will always come negative because the element at greater position will be lesser than the value at the lesser position. Are you getting what I'm saying? As we have sorted this in descending order, a of j minus a of y, here j will be the position which is greater than I. Okay, this is a condition, it must always hold true. So in this case the RHS, which is the difference, will always come negative because we have sorted it in descending order. Any two elements, and we take difference like the second element minus the first element, the second element minus the first element, second element minus first element, all these values come out to be negative, therefore they will be not equal to the LHS, which will lie from 1 to n minus 1, which is positive, right? So a negative can never be equal to positive, that's why this condition always holds true, and that is the solution to this problem. Okay, so let me show you the answer. Okay, I have not yet written the answer. I think I forgot to submit it. I coded the answer, but I forgot to submit it. But that is the approach, that will any given array that is there, will sort them in descending order and will print it out. Okay, so that's the solution, guys. Thank you.